Okay, good afternoon, everyone, and welcome to our last session of the season. Today we have PTV experts Bill Cisco and Adam Lynch on a presentation on PTV Vistro going into microsimulation.
All right, thank you, Tiffany, and it's good to be back for PTV Talks for the Vistro session. And yeah, today's agenda, it's going to be a little bit different than some of the PTV Talks, especially for Vistro that you may have attended. It's going to be a little bit more hands-on, a little bit more open-ended. So Bill Cisco is answering questions on the chat, but if you have a question that may pop up during the presentation and we kind of think it's a good one, maybe we'll pause the presentation for a few minutes and have some feedback and questions as well on this call. So some of the slides are a bit text heavy, so kind of bear with me on this, but you'll see why, because I was trying to document a lot of the things that I think you might find helpful when you're going from Vistro to Vissim when you do this on your own. So today's agenda, you probably read it all already, but part one is we're going to be looking at how to set up the Vistro model for Vissim. And we're going to do this more for like a basic case, not necessarily the advanced cases, because we have another PTV talk, so I'll share with you in a second, where we did more advanced cases. So we'll look at intersections and geometries and just kind of things to see there. Then the second part will be the traffic signal setup and focusing on tips and just kind of have like a checklist of things you can drill down and go through to make sure the signal's set up right, especially when you're migrating it over to the Vissim side. And so we'll give some tips there. And then part three, importing into Vissim. We don't talk about this feature a lot, but adaptive A&M is a very great feature, especially from the Vistro side going into Vissim. And so we'll highlight adaptive A&M. So I think that might be worth your time to listen into. And then selecting specific intersections for the export, so you don't have to export the whole model. That will be another part in there. And as far as deciphering some of the error messages that you might be seeing from the signal side going into Vissim. So we'll look at that part on the import. And then at the end, we'll wrap it up with some typical next steps. There is, of course, some modeling checks, especially when you're doing some conversions, going from Vistro to Vissim. Again, in a checklist format, I'll highlight some potential things and potential solutions, and then some general calibration topics you might want to follow up with as you go. So hopefully by the end of the session today, you'll see that it's easy to get into Vissim, and it's also very flexible at the same time, and something you'll find beneficial. So I mentioned these resources for advanced topics. So it's like advanced Vistro models going into Vissim. We've talked about this before. It looks like I clicked on these links previously, but so we do have this knowledge base page, which is linked in that first upper box of the slide. And this really goes through a lot of advanced cases, and it's broken down into some tutorials and things you should pay attention to and how you should organize the structure of your model. Super detailed stuff. Today, we're not going to go into a lot of this information because, one, you have this resource. But the other thing is, at the end of this knowledge base article, there's a video from PTV Talks, and this was part 6 that we did. I can't remember what part we're currently on, but it's much further than 6. But if you play this, it goes over this knowledge base article and an hour webinar, but also goes into other advanced details and things to look out for when doing these advanced interchanges and intersections. So if you're interested in this really advanced stuff, this would be a really good resource to go with. All right, so let's close that down. Next, there's some other advanced use cases, one being the DTA use case, so dynamic traffic assignment. Some of you may use that for Vissim. You can do this in Vistro and get it set up for a dynamic traffic assignment model in Vissim by using the zones for the trip generation. So you get the ins and outs using the trip generation zones. And then you eventually go through the distribution and then the trip assignments. And when you import that into Vissim, you get the matrices and you get the zones and parking lots and pairs if you're familiar with DTA and Vissim. We do have a example file and documentation on this, so you can see what that looks like and explore that a little bit further if you're interested in that topic. It's a good resource. Then we talked about this in the last PTV talks. We have patterns now in Vissim. So there is another example file as well as the last PTV talks that we did that goes through how to add patterns to intersections and how to update all of that information on the Vissim side with patterns. So again, if you're interested in that topic, those are some good resources for that. So once more, we're focusing more on the basic side, more of just kind of like the general checklist things that you need to do in your model, and a lot of the error checking and stuff. So our first part, setting up your Vistro model for Vissim. And you can see on this picture right here, we're showing the intersection setup workflow. That's that first button within the workflow panel, and it says intersection setup. So within this tab, I highlighted a lot of rows, I guess, just to kind of show the typical things that you might look at. And then also I did highlight, maybe you should look at these things first before you start looking at some of these refining, fine-tuning type of features to save yourself some time. Because if you change these things up top, it's going to potentially change the crosswalk location, change potentially where the radius starts and ends, and maybe where the stop line and all of that stuff is at. So work on these first, and then after you get the intersection set with these, then go ahead and do these fine-tuning tools, as well as measuring off the base map for any distances or something like that. And I'll show you kind of how this interacts on the Vistro side in a second. So you look at some of these tables in Vistro and you say, wow, there's a lot of stuff there. Maybe that's a little too overwhelming for me. We do have a search bar that is used sometimes by users, and they comment how much they like it. I personally like it myself. You can start typing in that search bar, and it does filter down this list to whatever you're looking for. So for example, if you're looking for medians here, once you start typing in MED, and then hit enter. I don't even know if you have to hit enter. I can't remember. It does start actually filtering it down, so the median elements will be the ones that pop up. So it is a way to kind of make this table a little bit more manageable to work with. But yeah, of course, you want to set up your lane configurations and make sure you have those correct. Then set up your lane widths and as well as speed limits and things like that. The reason why I said skipping the exit pockets and lengths, when I jump into the product, you'll kind of see how those are related. If you push back your intersection distance and make your intersection bigger, then your turn bays actually get pushed back as well. So that's why I'm saying make sure you get the lanes and everything all figured out, and sizes all figured out before you start focusing on turn bays and stuff. Yeah, and then you're going to be looking at your median sizes. Do you have medians? How big are the medians? Stuff like that. We also now have the channelized turns. We've had that for a while, but the new feature is this target lane where you can actually assign a turn to a lane. And in Vistro 2024, this target lane will actually visually show up correctly in Vistro. right now, it does show it a little bit, but it still leaves a little leftover for the target lane. But on the Vissim side, the target lane works just fine. All right, so then, like I said, after you work on these general topics, then you can go into some of these fine-tuning things, like looking at those pocket links and exit pocket links, and then looking at the radius sizes, approach offsets, which here is in this section right here. This moves the intersection approach to the left or right of the center line, and then stop line and crosswalk setbacks. So let's take a look at this in the Vistro side. So I have a model kind of set up. This model we've been using for a while. It's in Denver, on the border of Denver and Aurora. And it's a nice basic intersection or basic setup to use. It shows the radii, it shows the channelized turns, it shows some freeway elements and stuff like that. So it's a good example. If I zoom in a little bit closer, one thing that I would say sets us apart from our competition is that we do have a transparency mode. If you're a Vissim user, you probably use Control A to just kind of go into your wireframe mode. We also have that same shortcut in Vistro, so no reason to learn anything differently. You just use Control A, and you can see underneath the map itself. As well as if you go into the settings here and you look at my network, there's also a opacity toggle, and you can add a little bit of fill if you think you might want to see a little bit of fill, if that helps you or not. Let's just leave it like that maybe. So I've already kind of done a lot of the work here. So I've lined up the crosswalks, I've lined up the stop bars, I did the turn radii and things like this. So let me show you where that's at. Again, the intersection setup tab is the workflow here. Some of the things that maybe are challenging for people is to know what the lane widths are in certain softwares. With us, we have this transparency mode, and we also have this measuring tool. So it's quite easy to kind of just measure the lane, and it's in feet. You can change it to meters if you're somewhere else. So you can kind of get a rough guess on the base map, how wide is that lane? So it's about 12 feet, or you can take all of them and kind of guess that it's 48 feet. As well as look at the left turn lanes, which sometimes are different. You can measure those and say they're about 10 or 11 or something like that within that. So we do have a really good way to quickly look at these things. You can also look at the median. It's a 10-foot median that they have separating the two sides of the roadway. And like I said, once you get all of this set up with the radii, the turn, the approach offsets, then you can actually go in and look at, how far back is my turn lane? So it's like maybe 100 and, 170, 175 feet, depending on how you want to interpret the taper or something like that. I know people do that differently. But one thing I do want to show, this crosswalk here, it's maybe not lined up so well. So, and also it looks like the width of that crosswalk isn't exactly right. So I can look at the width, and it's about 10-foot crosswalk. I think I put in an 8-foot crosswalk. This is the westbound approach. So you can look at the arrow here and see you're on the westbound side. If I go down, let's use the search bar and type in cross, I can see the crosswalk settings specifically. And for the eastbound side, I can see that, let's see here. Yeah, the width is 10 feet, so I do have it right. The setback, it needs to match up a little bit maybe on this side. So let's just look at the end here and go to the end on the base map. And it looks like I need to give it another 8 feet on the setback to line up that side. So if I do a -8, it would actually go into the intersection with setback. But if I do a +8 and type it in, then, oops, I first have to actually select the right intersection. Sorry about that. So yeah, so it's 8 feet. I already have 3, so I need 5 more feet here to get 8. So if I type in 8, then you can see that the crosswalk moved back from the center of the intersection, and it's a little bit more lined up on this side. Now it's skewed a little bit, so you're just going to have to make the call which side of the crosswalk do you really want to match. And also, it depends on where your stop bar is, I would say, too, to kind of make that decision. Yeah, I'll leave it up to you to figure that one out. There's another thing called stop bar. So typically, it's about 4 feet between a crosswalk and a stop bar. So that's what the standard distance is in Vistro. But if you need to give it a little extra, there's the stop line setback. Maybe you have to give it an extra 3 feet or something like that. You can see that then the stop bar will also move back a little bit. So those are some of the fine details that you can do within Vistro. Other things are these approach offsets. So you can see like this intersection has a -4 value, which means it will go to the left side of the center line. If you're an engineer and designer, that makes complete sense. If not, you might find it a little difficult, but it's a -4 is to the left side of the center line. And if I put it back to 0, just to show you what happens, you'll see that this southbound approach will move. And yeah, you can see that it moved over 4 feet. But this is how you can line up the legs. And you saw that this crosswalk maybe moved too when I did that. So that's why I said these fine-tuning features you kind of want to save to the end. All right, so those are some of the intersection geometry settings, and we can continue into the traffic signal setup. Again, I kind of have a list here of traffic signal settings. So in the workflow, if you go into the traffic signal workflow, which is the traffic signal, which is obvious, then you pull up this dialog, and I highlighted some of the things that you might want to look out for when you're putting in a signal, and especially going to Vissim. There's some common things we've seen from some support tickets that I also highlighted in here. So my first tip is, if you can use the newest version of Vistro, I would highly recommend it. We are light years different in functionality from where we started, probably in like version 5 or so of Vistro, to where we are now in 2023. There's a ton of new features, especially signal features and tools that you can use to help set up your signals. So I would highly recommend that. The other thing I would highly recommend is to use default signalization when you can to set up your signals. This will help you make sure that the splits are set up correctly, the sequence is set up right. Also, it will even check some coordination boxes for you and things like that. Maybe even play some detection if you need to do that as well. But that default signal is this little traffic light that I've highlighted up at the top. And if you click on that, it will actually run through the process in setting up a signal. One thing we've recently added is patterns. And again, if you were on the last PTV talks, you saw us talk about these active patterns. You can add now many patterns to Vistro, meaning you can have multiple timing plans assigned to the controller. That's good if you do it right. It's bad if you add a bunch of patterns and forget to change them and modify them correctly, because when you do bring them into Vissim, that's more opportunities for errors or something to pop up if you neglected to update those patterns correctly or something like that. So just be on the lookout. If you're using patterns and going to Vissim, make sure they're updated and all the errors and things are worked out first, because Vissim will tell you if it's not. And you'll see that in a little bit.
Adam, sorry to interrupt. Adam, there's a number of questions, and one of them has to do with errors. Are you at a point where you want to take that, or do you want to wait a little bit? Since you
So
just
I have
mentioned
a signal error slide, probably in a couple slides.
Perfect.
Yeah, and
All
I
right,
think we could take it there.
Sounds good.
Yep. All right, so other things are making sure that you have the actuation type set up the way you want it in Vissim. Sometimes people set up a fixed time controller and they're like, why do my detectors not work? Well, okay. So you need to make sure that these are set up correctly, especially if you're bringing it into Vissim, as well as offsets, references, and things like that. Control type is another thing that we see sometimes. Some people are not setting protected or protected permissive correctly. So maybe look at that one, especially overlaps. Overlaps is another thing. So maybe you need to kind of look at how to set up overlaps. Max green is another thing here. This is older versions. Max green can give a lot of warnings, especially if you've neglected this. In older versions of Vistro, it defaulted to 30 seconds, but in newer versions of Vistro, and Service Pack 6 was just released today with the Max green feature in it. I'll show that in 1 second. This fixes a lot of the errors as well. So that goes back to my first point. If you can use newer versions of Vistro, do it. It can save you some headaches. And then, yeah, I mean, some of these other things, make sure you have your splits entered right. If you don't have your splits entered right and one's short, you'll get an error that, your splits aren't set up right. Same thing with pedestrian times. If they're too long or not, you don't really have any time in your cycle for pedestrians, then you might get some errors for that. So it's pretty standard stuff. I think when you guys start your next model, you can pull up this presentation and use this kind of as a checklist to go through and set up a signal. All right, so let's see how this max green calculation works now. So I am in Service Pack 6. I just downloaded it fresh today. And if I go over to my traffic control tab and scroll down a little bit, you can see that there's this max green row here. And what max green does, it's by definition, it's basically the split minus the all red, minus the all amber, minus the delayed vehicle green. And that is the maximum amount of green that you can have in a split. And like I said before, in Vistro, this was defaulted to 30, and users either had to go in and use higher levels of subtraction math to figure this out for all their intersections. And Vissim did give a lot of warnings if the max green didn't add up correctly. So we have this auto calculation, and for example, if I started a new intersection, let's go in and just create a new one here. I'll have my max green. Let's put in a volume set too, just so there are some volumes. Okay, so we'll just do permissive protected on 2 of the movements, and now I have to make a permissive protected lane. Okay. So if I go ahead and use the default signalization like I recommended, I should get some sequences and also some splits. So I'm going to click lead. in this case, and now my signal is set up. And what happened is now this max gain is now automatically calculated for this particular intersection and with this particular intersection. And before, like I said, it would have been 30, but now it's actually real values. But I might say, hey, you know, this left turn is a little short. Maybe I want to make it longer for these vehicles. So if I change the split on signal group 2, so signal group 2 is right here, and you can see the max gain is 45 seconds. I'll highlight it. If I change this split, now it calculated to 41 seconds because I took off some of the potential time it had. And if I do signal group 6, it will also change the 41 seconds. And then if I make the lefts longer to 15 seconds, you can see that now these are 11. So it's saving you a lot of time to enter those fields right there. So that's pretty special. All right. So that's the traffic signal setup tips. I'm going to delete our intersection here, and we'll go into importing. I think I'll skip to the question first, and then we can go back and look at the adaptive and the select intersection. So let's go into this, the error message and logs thing, since that question came up. So there are two places where you can look at messages within Vistro. If you go to the view, and then there's the message file and log file, you get two separate text files with information. The message file is probably the best one, I would say, to look for signal errors. So if you see this message that pops up within Vistro, it says at least one of the RBCs isn't set up right. You can go into your message file and then probably scroll down to the bottom. That's usually where those are. And then you'll see some sort of message. It'll see like, we can't start the simulation because the signal's broken. This is what's wrong with your signal. So it says, warning, signal controller 2 in pattern 1. So you have to go to that active pattern 1. It says the cycle length is greater than 0, but no signal group in the sequence is marked as coordinated. So if you decipher that entire text message, it basically says one of the coordinated signal check boxes is checked off. So you could go back into the signal and check that, and I'll show you exactly what that means. And then probably after you fix that, then that will then work. So let's go back into our example file. And I'm going to do exactly this. Right now, all of the signals work. But I'm going to say I accidentally forgot to check this coordinated phase in here. I didn't use default signalization. It didn't do it for me, and I forgot to put it on there. So if I go ahead and then try to run the Vissim previewer, I'm going to get this warning message that this controller doesn't work. And at first, if I have 50 intersections, I might be a little distressed, like, what does that mean? So I go to view, and then I go to message file, and then I pull up the message file. It basically says that same warning message that right here. So it says signal controller 1 in pattern 1, cycle length is greater than 0, but it's not marked as coordinated. So if I go ahead and then mark those two back at coordinated again, I'm going to probably get a whole bunch of simulation things pop up, but let's just keep doing this. So I hit preview and Vissim one more time. Now nothing popped up, so it is actually sending this over to Vissim for the export right now, and then you'll see the simulation play. takes a few minutes sometimes to get the simulation and the network previewer rolling. So sometimes be patient. Another thing, so I mentioned, maybe signal group 6 split, you accidentally didn't drag it all the way to the barrier or something like that. Again, if I go to view message file, if I go to simulation preview, it says one of the signals doesn't work. And if I go to the message file this time, we can look at the latest message here, and it says warning signal controller 1 and pattern 1. The sums of the split values are inconsistent across all rings. It sounds very, very, very serious. But then you look at it and you say, well, okay, that's a split kind of thing. Maybe I should check and look at my splits at that signal. And I look at my splits and I say, oh, it's not there yet. Okay, so I drag it back over, and then I go ahead and preview in Vissim, and then I don't get the warning. Lastly, the same thing can happen with crosswalks. Right now, all my crosswalks are per FHWA, where we're starting and ending at the, ending at the green and starting at the yellow. Some cities don't do that, just so you know. But we could get a warning message if the flashing, well, let's just change, what is that, signal group 2. So if I look at signal group 2, I can change the walk. Let's make it 7 seconds, which should put it somewhere in the yellow. What happens this time? Uh-oh, there's a problem here. So yeah, we are aware that this isn't always the case, and you may get some issues with the Vissim simulation. We are looking into this to make sure it is a little bit more flexible for typical cases where crosswalks are kind of in the clearance intervals. We read the manual a little bit too literally, but yeah. So let's look at the error message there. It says this time, basically, it gets into the walk. So if you start seeing walk and flashing, don't walk, and then, some of basically all these elements here, it's a crosswalk warning message. And if I go in here and actually change that back to what it's supposed to be and hit simulation again, I don't get the warning there. So that's a crash course on warning messages. One other place you can actually see the warning messages is in the Vissim warning screen itself. So you have another opportunity when the preview loads to actually see the same warning messages that are in that message file in Vistro. Sometimes they give you more warnings. We're going through this every service pack and trying to clear out as many warnings as possible since we redid the RBC controller to give you the best information. So again, try to stay updated with your software on that. So Bill, I hope that answered the question on warnings or maybe helped.
Yeah, hopefully. There's some very specific questions, so it depends on, we're getting some great interactions here today. Usually we get good questions. I do have a few that, if you time permitting, want to go through now, or we can hold them until the end and just circle back as usual. That might be a better way to do it, given where we're at. Kind of your call. Yeah,
let's handle that at the end, and we'll make sure we can get through the adaptive A&M first, and then some of the calibration stuff to look at. All right, so adaptive A&M, that might be a new term for some of you who have not used adaptive A&M yet. But basically what it is it updates the changes since the last A&M adaptively, not to use the word in the definition. So I'll show you what it does. But for a Vistro to Vissim user, this is perfect for signal timing updates. It's also really good for static route volume updates and things like that. as well as some very, very basic geometry changes. One thing to note, I mean, adaptive A&M does do a pretty good job, but I would say you would be more successful with it if you are sticking to more minor changes that don't change a lot of the linked node structure. So if you're splitting legs in half in Vissim and in Vistro, you're adding a whole bunch of new intersections and stuff like this, then it starts to kind of fall apart a little bit. But if you're really sticking to the same basic linked node structure, I would say overall it does a really good job at piecing all of the elements together. So let me show you how this works here. So here's our Vistro model, and you can see we have 115-second cycle length throughout our corridor. There's a cycle length, and we have the splits that are set to whatever the 115-second cycle length is. And here you can see we have this right turn volume, which we'll highlight often. In this case, it's 50 vehicles for the existing condition. So we have this existing scenario with the 115-second cycle length. We're going to export this using the Vissim A&M, and this will create the A&M file with the RBC controllers. We'll click export, and it will go into our browser, and I have a folder set up for adaptive A&M example, and then we'll save the file out. And now we'll migrate over to Vissim in a new file here. And we'll go to File, Import, and then you can see that the A&M option is in bold, but the grayed out version, or the grayed out option is the A&M adaptive. So we'll select the A&M, and here we'll select our file that we have, that we just saved out from Vistro. Look through the options. We like what we see, but we'll save now the Vissim IMPX file. So we have to give it a name for the output. And then we hit save. And then from now on, we can hit import. And when we import the model, you can see that it matches very closely to our Vistro network that we previously had. We have the same intersections. Please note in this existing condition that we have 115-second cycle length. So if we want to see what was imported, we can zoom in a little bit closer. Let's take a look at the signal controllers and see what timings came in for this first intersection. So you can see we have 115-second cycle length, which is what we expected to come in. And when we select this intersection, we see that our splits also match. Let's confirm intersection number 1 right here. So yeah, it's 18, 36, 11, 50, and that's exactly what we have on the Vissim side. So that was a nice clean import. Let's check the volumes here. So we were looking for a volume of 50 in our Vistro model. So 49 is for cars, and then 1 is for vehicles because we had 2% trucks. So that checks out, and that matches that turn that we had for the right turn here. All right, so our existing is in Vissim, and it's all set up. But let's say, hey, we want to study another scenario in Vistro. This one is 10% traffic growth. So I did the multi-change tool to change the traffic and increase it by 10%. And you can see the increase there. As well as I changed the cycle length now to 120 seconds instead of 115 seconds. So you can see that this scenario now has 120-second cycle length, and the splits add up to that. So we're going to go and export this A&M file out so we can import these updates and changes into Vissim. So it's the same process, RBC. We replace the old file that we previously had for the A&M. That way Vissim knows that there will be a change. And when we get into Vissim, this time when we import the A&M file, you can see that adaptive is also in black now instead of gray. So we'll go ahead and select adaptive. And with the adaptive, we select the same A&M file. We look at the same settings. We're going to overwrite the Vissim model that we had before because I have two. Yes, I want to overwrite it. And so we bring in the new A&M from Vistro, and now we can see that here, hopefully we'll have 120-second cycle length, and we do. Now let's go ahead and check the splits for intersection or controller number 1. We have the 20, 37, 13 is the first 3 splits. So let's click over here. Now we have 20, 37, 13, 50. So it all adds up. So now we successfully imported new traffic volumes. We have to check that. It's 55 for that right turn. So let's check the static routes again to see if we have 55 coming in on that right turn. And we have 53.9 for the cars, and the trucks will be 1.1. Remember, these are relative for the static routes in Vissim, even though in Vistro they're exact volumes. But based on the input, it'll all come out right. Now let's change this Vissim model a little bit. We're going to change the geometry just to show you what adaptive is actually doing. So we extended this leg a little bit, and we're making the geometry look pretty nice. Okay, and back into our Vistro network, let's now look at this 20% traffic growth. And it has 125-second cycle length now. You can see that, yeah, 125-second cycle length. And now the turn here is a volume of 60 vehicles because of the traffic growth. So I'm going to export this one now to Vissim A&M. Again with the RVC, overwrite our last file, hit save. And back into Vissim now, you can see that we still have that change there that we made, but we want to import our new cycle lengths as well as our new volumes. So we go to import adaptive, save our file, and again, select the A&M, hit open, and then save the output as our same old Vissim file and hit import. Overwrite. And as the changes are being brought in this time, you can see that the geometry is actually still there. So this time it's keeping the Vissim geometry that we previously had, which is really cool. And if you look at the traffic controllers again for signal controller number 1, you go to edit time. You can see now that we have 125-second cycle length with the geometry we had before. And our splits are 21, 40, 14, 50. And we look at intersection 1, we have 21, 40, 14, and 50. So we have the same splits that we in both softwares right now. And again, if we check the volumes here, we'll go to the static routes and see that our volumes match from Vissim also to Vistro. So oops, I pulled up the truck route first. So the truck route, we have 1.2 vehicles in the relative flow, and then 58.8. That, of course, adds up to 60, which is exactly what we had in Vistro. All right, the next thing is selecting the intersections to actually export. So there's some people that do this accidentally or on purpose, but there is this analyze intersection button or checkbox, and if you check it off, then that means that that particular intersection will not be exported to Vissim. And if it's checked on, then that means that intersection will be imported to Vissim. And within Service Pack 6 of Vistro, we did fix this OSM error or bug that we had where anything importing from OSM was checked off automatically. So now anything importing from OSM will automatically be checked on. So there shouldn't be any mystery anymore on why OSM elements are not importing. Okay, so this is intersection selection. So I hope we can get this to work right now. What I'm gonna do, since I have a small network, I'm just gonna manually uncheck these just so you can kind of see what I'm doing. I'm gonna keep this middle intersection. So I'm gonna check this off. Maybe it's because I didn't save my network. I'll have to check. All right, so I checked the analyze intersections off, and then only this intersection is on. So this, in theory, should be the only intersection that actually comes in when I create a Vissim export. And this here, then you would just do the regular export to Vissim. So this would be the Vissim A&M. It also works with the previewer as well, but we'll do it this way. So A&M export with RBCs, hit export. And I'll save it right here as the select export A&M. Okay. And let me make sure I'm in the right one. So now I'm going to start a new file here. And so I said I want to import just this intersection. So when I go to File, Import A&M, and pick the Select Export one, which should just be one intersection, I hit Open, and then I save the output as Vissim, and hit Import. It should just pick the one intersection right there, and it did. So here's the one intersection now, and it deleted, not deleted, but it just didn't export the other ones. So this is really valuable if you have a large Vistro model and you really just want to look at one corridor. You can also do A&M like this going into this one. All right. So let's keep going to typical next steps within Vistro. So some things you might want to look at is, maybe when you're reviewing the model, cars might be going too fast or too slow. Probably this has to do to the Vistro speed limits weren't actually set up correctly. So if you had a slow speed limit on a freeway or something like this, or on a highway, you need to make sure you check the speed limits. Some other things, conflict areas where you have this red, kind of like what I'm showing right here. Sometimes in very congested areas, this can cause some artificial grid locking because maybe this right movement is blocked and it kind of spills into just a little bit in the intersection. And then when it happens, everybody stops because this is red. That may or may not be the case, but it might be something to check sometimes if that's a problem for you. Sometimes detectors are not working. Again, when you're in Vistro, make sure that you have the detector settings correct, including the checkboxes. Maybe it's the location of the detector it wasn't set right, or the length. Sometimes if somebody enters 0 for the detector is so small that the car is never on it. So make sure you get the detector settings correct. Sometimes PEDs are not moving. Again, here is you want to check to make sure pedestrian recall is set, or maybe your controller type's semi-actuated or something like this, and somehow you coded the pedestrians incorrectly or something. But yeah, that's one thing to check in the pedestrian settings. Crosswalks in the roadway. So with crosswalks in the roadway, typically what happens is this crosswalk length, sorry, I'm zooming, it's going to be a little slow. This crosswalk length that comes in is actually the crosswalk length that is in Vistro itself. So if you didn't account for the turn radii when you developed your crosswalk length, sometimes these crosswalks can be a little short and the signal will actually be in the middle of the lane. And if that happens, then some of these red errors propagate and everybody stops because the pedestrians are standing in the middle of the road. So in Vistro, going back to the intersection setup, we do have the crosswalk length down here where you can measure and enter the crosswalk length correctly to go in. Some other things, crosswalks are skewed. So on the Vissim side, you probably have to fix it on Vissim because we can't do skewed crosswalks in Vistro. Yeah, buffers of turn lanes or offset turn lanes. Those are local things that you probably are going to have to fix on the Vissim side. I mean, operationally, you'll get the same result in most cases, but if you just want the visuals, you need to fix it there. Some other things are, I really get a lot of vehicles maybe in the middle of my model, or maybe I don't get any vehicles in my model. It's probably some balancing issue. So you can balance the intersections in Vistro. That helps form the volumes in Vissim. And the last two here, if you have right turn on red on, vehicles will turn right on red in Vissim. And if it's off, they won't. So make sure you have the right turn on red settings correct. And lastly, if you don't have a Vistro volume, with pedestrians and with vehicles, you will not get a route generated in A&M. And one specific thing with pedestrians, if you have like a pedestrian volume of 1, that has to create 2 links in Vissim for the crosswalk and 2 routes basically. So it's just going to create it for one direction, not the other direction. Just something to be aware of to make sure you have volumes to get routes. All right. And we're getting towards the end here. So with the calibration, kind of the first things you want to take a look at before you get into the specific calibration on the Vissim side is probably just changing your lane change distance. Maybe that comes in a little too short in Vissim. It defaults to 200 meters or like 650 feet. A lot of times I'll even just change everything in bulk to 1,000 just to see what it looks like. Yeah, emergency stop distance may be another place. Another thing is this target lane, and we're looking into this as well in development side. But Vistro automatically will generate a connector to the right-hand side of the road. This may be correct in how people actually drive, but in a lot of cases, they'll tend to just go straight across, even though they're supposed to go to the right. But yeah, just double check that when you have lane imbalances. And then you can just flip that connector to the correct place. And then lastly, you have static routes. This by default will be checked if you use static routes. And you can combine these together to kind of create like one long flow between intersection to intersection. So that's definitely something you really want to look at, is the static routes. For more advanced settings, yeah, if meters are in imperial units, definitely change that to whatever your local settings are. We talked about setting up patterns. Patterns depend on the time interval bends. So if you have specific time intervals, you need to end up setting those within Vissim itself. Maybe you have some fleet considerations, so the default vehicle fleet isn't great for you. You can go ahead and change the vehicle models, types, classes, things like that. Some of our competitors also, have some basic fleet settings. I mean, we can also do those exact same things with the Vissim side by changing those fleets. And then lastly, make sure you have your evaluations turned on if you want to see your result. So if you go into the evaluation settings, you can turn on the link results and then the actual node results, and then as well as make sure you have travel time markers for travel time results. So we do have a lot of really good evaluations you can pull. You just need to make sure they're turned on and the times are set for the right place. Okay, so we're going to end there, and we're going to go into some of the Q&A. So shoot away, Bill. What do we have?
All right, yeah, well, I think I'll start out at since we're at the end of the hour with just saying, if for some reason we don't get to it live, I have answered a bunch of these as we went along anyway. There's a number that I did say we'll talk live about. If for some reason we don't get to it or you need to peel off beforehand, this will be part of the recording, or we will answer your question. I know once we start the live, I usually end up getting a bunch of other questions added, as I'm going through them. So we might not get to them all, but we will definitely follow up. So there's some very specific, like how to do certain timing when you have certain things happen, Adam, that I mentioned. That some of it had to do with error messaging and so forth. But maybe some of this is some guidance questions. So we always have a caveat between software guidance versus project guidance. So just as a reminder on that, and Adam, feel free to say that you don't want to answer it based on those grounds. But so the first one, I'll try to just keep these in order to make it, time sensitive. But when the PED split walk-in clearance interval is greater than the vehicle phase split, Vissim provides an error. So the two questions is how do you handle that in Vissim? And that Vissim will show an unusual cycle length, and does that same thing happen in Vistro as well? Do you have any comments on that?
Yeah, and again, this is a feature we're aware of. It was kind of an undesirable outcome from the update of the new RBC, and we're aware of that issue. Previously, you could do it where you had the PEDs larger than the vehicle split, but it wasn't exactly being handled correctly either. Just because you could do it didn't mean it was right. So the feature that we have for this is actually going to handle this situation correctly, where things get kicked out of coordinated phases and then would have to kind of recycle back onto the coordinated phase. So it's going to be a little bit more sophisticated. I would say as of right now, what you could do is you basically have to make the cycle larger than what it is and kind of treat it as fixed time. It's the only real answer that I have. So like on the Vistro side, for instance, let me zoom back in. If I go to my first intersection and I want to say that, maybe this crosswalk is a lot longer, let's say like 10 seconds longer or something. I want to make this just 130 just for this one intersection. And then you can see how the cycle got bigger. And then for signal group 2, I'm going to add an extra 10 seconds to the walk. I know it's big, but or something like that. And then you can see that now it's probably going to add up to 130. I have to do the math really fast in my head. It's kind of hard to talk and do things at the same time. But it would be something similar to this, where that's then like how you could handle it on the Vistro side. But again, once you go into Vissim, it's going to say, something's wrong here. I would say on the Vissim side, you probably would just have to manually fudge it in. And if you have access to the older RVC controller, that would probably be the preferred solution right now, is to look at something like that. But yeah, but we're working on that one. It's actually on my list for the next quarter.
Okay, great. So let's move through here. First, a few things that were recurring themes. For those of you where it wasn't answered, or if you might still be wondering what A&M is, that's the abstract network model file format to move the network portion of the data from Vistro to Vissim versus the PRBC, which is the signal portion. And those are two different separate files. Another one is that I thought was a really good question that others may be thinking, which is, do all these details that you went through today, Adam, actually have an impact on the operational results? And so I'm actually just going to answer that here the way I answer it for this particular person, which is in our user's manual, we have duplicates of these tables that include for each entry line a column that says whether it's applicable to an HCM result or an A&M result. And if the A&M again refers to whether it will actually be used in the simulation later. So if you're curious, some of these things that Adam was showing, if you're only doing an HCM analysis, it's not as important that you go through all that level of detail because the HCM isn't that refined in order to deal with it, but definitely lane widths, right? But lane lengths, or, it always thinks there's an infinite number as an example. Okay, another one is...
I just want to add on to that. That's actually part of this help document that we have in the knowledge base. It says, understand your analysis objectives. And in this video, we did cover that specific case where you can do a schematic intersection in Vistro and get the deterministic result without a lot of effort. But when you start going into Vissim, you really need to understand what details you need to add to get the desired simulation result you want. So that's kind of the point of this advanced article and webinar. Sorry.
Perfect. Okay. And no, that's great. Another question regarding PED timing and so forth says, what's suggested to use for walk and PED clearance when the PED volume is 0 or less than 5, but the signal plan has walk and PED clearance, which will make a discrepancy with the minimum split. So I wasn't 100% sure if the question related to trying to capture cycle-to-cycle differences within the hour, where there might be a PED call or not, but or if you have a different interpretation of that, Adam, that you want to elaborate on.
Well, so there is basically the push button. So if you have an actuated signal, like this one's fully actuated, we actually have pedestrians shown or in the volumes. And if you do not have the pedestrian recall checked, that means that then there's a pedestrian probability in the back end of Vistro that is being calculated. And you can actually see that in Vissim, but you can't see it in Vistro. But that probability is telling you how often that push button is being pressed and what signal is being used for the green. So if the pedestrian's not there, then these max screen times can actually be shorter than what's shown, if that's the case in a fully actuated situation. In another case, like if you have it like fixed time or something and no pedestrians and you want to shorten it, that's probably something, legally you wouldn't want to do. So maybe that wasn't the question.
I think that brings up a good point too, is when you're using the fully actuated method within the HCM, there's certain ways that these inputs are going to look in the Vistro tables as the basic inputs, but the methodology goes through an iterative procedure to adjust things. So there's and that's just part of the newer methods since 2010 for actuation in the HCM.
So you see the snapshot of fixed time in the sequence, and that's typically how all of these deterministic softwares kind of work, is you'll see that snapshot. But when you go through the signal settings, and especially in these lane group calculations, you can start seeing the effective green times for fully actuated. Maybe the effective green times are actually less than what you've specified or more than what you've specified within this. So then you know the actuation's actually working.
Yeah, it's a bit of a behemoth, the actuated method in HSIM, quite honestly, but we implement it. It's just hard to show that in a static image, like you're saying, on the front end of it. It's more that's one view, and then you look into the detailed calculations in italic font lower in the table, like Adam was just showing, in order to see what's actually getting allocated eventually to the calculation. So really good question overall. I think we've answered as much as we can, but if there's more, feel free to email us later. Another question is, the max green adjustment based on splits sounds really handy, but does that exclude from an inhibit max situation where the main phase would take unused time from other phases? This goes back to when you're doing the default signalization or
Again, this is a snapshot. So we have force off option. So the side street unused time will go to the main street time. So even though the max green is, in this case, for signal group 2, it's 42 seconds. If this, I don't know, what is that extra time there, about 20 seconds or so is not being used, then it would go into the main street and make that green time 60 seconds or something like that.
Perfect.
Again, you can see that on this table with the lane group calculations. Actually, well, I guess correctly, it's 54 seconds is the effective green time for that one. So it is higher than what the max green says.
All right, some guidance questions here. I'm going to group these two together because they were asked by the same person and relate. Says several times when we get controller data, the sum of the splits across rings do not add up. Should we use the controller splits or revise it to make Vistro work? That's part A. Part B is the sum of the splits up to a barrier frequently doesn't add up as well. And what's the best practice to handle those cases?
That's a great question because it happens all the time. And being a consultant, I've had many timing plans come across that don't add up. That's the engineering judgment question, I would say. First, I would say contact the source and let them know maybe there's an error in their plans. But two, if they think it's right, then I would just adjust, kind of the best you can and massage the best you can to get it to work in Vistro so you could get the result that you need. But yeah, that's kind of like, there's a good answer and a bad answer. There's either ignore it or let somebody know or work in the middle.
Good. All right, cool. And Adam, I apologize. I may have missed this. There was a flurry of activity in the Q&A, and I didn't hear everything you had said. But the question was, can you import into Vissim as a second scenario under the scenario manager? Did you talk about any of that?
I did not talk about that. It's a good question. I never actually tried it myself. I should try it. I mean, coming from Vistro, if you have two scenarios, they will come into Vissim as one model. And again, you can use adaptive A&M. I suppose you could always create a second scenario, but I have to check to see if you can actually then import the changes to that second scenario. I can get back to you on that.
That was about as far as I got on my reply. Similar. I haven't done it personally, but I think it might be possible to adapt it. All right, so that's all great. Next question is, sorry, I think those are all the ones before we started the Q&A. So I put in the chat for everybody, there's a link for where we eventually have the repository for all of our previous versions of PTV Vistro, PTV Talks Vistro webinars that usually include the video as well as the presentation file and the Vistro files. that should be somewhere in the chat within this. This will be episode 14. Give us a little bit of time to get it up and posted, and you'll also get an email about that. There were a number of questions about getting the slides after. Is there a way to adjust origin destination volumes in Vistro? Not sure.
I think that's referring to kind of like the synchro-ish sort of thing where you have two adjacent intersections, maybe.
Okay.
I mean, within the Vistro side, I mean, like I mentioned, you could do like OD with using the trip generation zones, and actually, like in a model like this, you could put zones around all of your external legs and then actually just route it through with the paths. And so you would have OD for the whole model if you felt like you needed something like that for advanced situations. With the combined static routes in Vissim, I'm not saying they're perfect, but oops, I need to open the other one really fast so you can see the final one. I still have the one single intersection. With the combined static routes between intersections, it does a pretty good job of like looking ahead. So it kind of does basically what Synchro is doing with the OD and trying to figure out what lane you need to be in. Again, if you look at that lane change distance, then that will tell the vehicle like how far in advance it needs to be in whatever lane. So that's another thing you could look at. Where, I mean, Synchro is not really doing that, but you could do that within Vissim pretty easily. And then lastly, I mean, in Vissim, you can draw a static route anywhere, so, or a partial route or whatever you need to do. So you have a lot of flexibility beyond what Synchro can do in that particular case to figure out ODs and intersections and make sure you have the core and interchanges or something like that not backing up. Yeah, in that case, you would probably want to look at the advanced tutorial as well.
So since it's 15 minutes after, I'm going to ask one more question from this, and then any others that were there or still come in, we'll follow up with email. This question is more specific to Vissim, but are there some templates, spreadsheets, or other that are available for exporting results from Vissim so that you can easily and more efficiently generate delays, densities, LOS, etc.? Right now, it seems that part of the evaluation is heavily reliant on the user to set up. Maybe there's tools already available to make that easier, and basically looking for some output reporting from Vissim that is automated similar to the Vistro reports, etc.
Well, I certainly love the question.
Thought you would.
You may know I'm also product manager for our product Vissim Publisher, which is our cloud tool that's online, and we're going to have tables, and we already have charts and maps and stuff to do this. We are thinking about as well as doing something like that for Vissim, and that would be the perfect place to set up templates and tables and visuals to do exactly what was described. Okay, but it's not there yet. But it could be there soon. But one thing within Vissim, I mean, there are some examples within the example files. I probably couldn't find one off the top of my head, but they have the layouts saved, and you can set up certain charts within Vissim using the chart tools. And with those chart tools, then, like maybe you could say, I want to look at this metric versus that metric at this node versus that node, and you can get a lot of that set up, as well as the lists. I mean, I know sometimes like here's my static route list, but you can export these to Excel, and you can also save, once you save the model and the layout, it kind of saves that list for you. The key is this layout file. So make sure when you're saving and you like how your Vissim model is set up with charts and tables and configurations, to save your layout file. And then you can also save it as default. And so the next time you come into a model, that layout will also kind of be there. So that helps, I think. But I do understand there's a lot of spreadsheet exercises going on when you get into the evaluation list as well.
All right, perfect. Well, I'll pass it back to Tiffany to close us out, but thank you all for staying on and for all the great Q&A throughout. And thank you, Adam, for your presentation. Tiffany?
Thank you. That is the end of our session for today and the season. We'll have more sessions coming in the fall. Thank you for everyone attending. And just a reminder, we'll provide a recording of the session sent in a follow-up email. If you have any questions, feel free to email us at marketing.us@ptvgroup.com. Have a great day and a great summer.